Okay, for the next set of reactions, or part 2, we're going to test the effect that changing temperature will have on our reaction rate. So I have one tube that's going to be at 0 to 5 degrees, one at 35, one at room temperature, which I measured at 23 degrees, and one I'm just calling hot for now until I figure out how hot it's going to be. I'm going to put all but the room temperature one in a water bath, which is set up down the bench here. This is a cold water bath, and then there's a warm and a hot way at the end. I'm going to put the tubes into those water baths for at least 5 minutes, if not longer. Then I'm going to actually make like a mini water bath that I'll put the flask in that's at the same temperature to try and maintain that temperature. I'll add the enzyme for each one, which in this case is going to be 10 drops of enzyme, and then I will run all the samples on the computer. So number 1 is put the tubes in their different temperatures at least for 10 minutes. Create a mini water bath of the same temperature here. Pour the substrate into the mini one, add the enzyme, put the little reader magic wand in, turn it on, and let it go. So this is the run at room temperature. You can see if you go way up here, which it won't probably let me because it's still running. It started at 14% and it's going to end somewhere around 16%. And I ran the room temperature one first just because I didn't have to wait to equilibrate it in a water bath. So what I'm doing over here is, this is my cold water bath, which is currently at about 1 or 2 degrees Celsius. I have filled up this little bucket with the same ice water that's in the bath, and then I put my flask that I'm going to pour the hydrogen peroxide that's been sitting in the bath for over 10 minutes. I'm going to pour it in here. So the reason I'm setting it up this way is so that the hydrogen peroxide does not warm up during the course of the experiment. Then I bring it back over here, and I'm going to add my 10 drops of enzyme. 1, 2, 3, 4, 5, 6, 7, 10. I'm going to do the swirly do. I'm going to leave it in the ice bath, put in my little meter, and then come over here and hit run on the computer. Okay, so now I'm looking at the results. This is for the cold water that's in red, or the cold temperature. This red line is cold. The green line above it was the room temperature. You can see, if you look carefully, that it started somewhere up here. It's probably about 14. That seems to be our general, our general starting value is 14 something. And we're only to 14.81, and our temperature in our little bucket I've made over here is still only, it's about 3 degrees now. So not going nearly as quickly, not as much oxygen produced as at room temperature. Hello, so now I'm doing the warm water bath, which is currently at close to 50 degrees. I have filled up my little red bucket with some of that warm water. I'm going to put a thermometer in it, and I'm going to pour my warm water hydrogen peroxide into my flask. I'm going to come over and I'm going to add the enzyme to it again. Drops, swirly, swirly. Stick the magic wand in and go. Okay, now you can see this blue line. That was the warm bath, which is now at about, it was 45 degrees, now it's about 40 degrees. So you almost see it went up. It went up a lot higher than room temperature, definitely higher than the cold one. Now I'm at hot water bath, which is about 73, 74 degrees, pretty hot. Get my beaker in there, flask, I mean. Fill up my little boat with hot water too. Pour the hot buffer in, the substrate. Come back over here. Add my 10 drops of enzyme and put in my magic wand. Ready, set, go. Okay, this is the last run. You can see this orange line is the hot sample, and it kind of went up. It's hovering around 16.8, I would say. Started at high 14 and went up to about 16. And I'm going to add one extra run for an extra boily hot sample. So this is a sample I put together from buffer that I actually put in almost boiling water to equilibrate. And then I added the enzyme, and you can see it looks cloudy. It's not very bubbly. I'm doing this sample because one of the interesting things about enzymes, as you raise up the temperature of the system, you generally expect to see a rise in the increase of product production. However, when it gets really hot, like say in this case up to 95 degrees Celsius, that's way too hot usually for the enzymes, most enzymes. And so instead of seeing a huge increase in production of O2, we might see not a whole lot of O2 at all. Okay, so this is my extra run I added, the purple one. This was with putting the buffer in boiling hot water and then seeing what happened to the enzyme. And you can see that the purple line kind of goes, it's either straight across or it's heading on down. And what I have to do next is help you guys fill in these tables on page 53, the slopes at the different time intervals. So I'm going to do that. Again, what you want to do is go find that tangent line. I think this is it, right? Click on it and fill in the tangent or the slope at half a minute, 1 minute, 1.5, 2, and 3. And then I'll get the maximum slope. And I'll show you what those, I'll fill this all in using this data, and I'll show you what it says. So here's the data for the table. I'm going to take a picture of it. This time I've got it for 0, room temperature, warm, the hot, and then the boiling hot one. And you'll notice that the slopes for boiling hot are all negative numbers. That's because essentially no change happened at all. And then these are the maximum slope numbers. I'll take a picture of these too.